All right, hello everyone. My name is Adam Wilson. I work for Perspective Software, a small software company up in Seattle. And today I'm going to be talking about moving C# code to D because all we write now is all in is C#, and we would love to not write everything in C# because, well, Microsoft is only part of the programming world. So, as I was writing this talk, I thought, okay, well, I'll just go over some basic steps. How do you move this C# to that D? And it got too long, like 4 or 5 hours worth of talk, and I was told that that wouldn't be acceptable. So instead, I picked one of our things that we use internally and said, well, what would it take to port that to D? And so we're going to go over some basic syntax, then we'll get into properties, namespaces, and I'm labeling everything in their C# names, and then as we get into them, I'll draw out where they fit into D. And then finally, we're going to finish with the thing that I can't do in D yet, that if I could, I would start moving stuff. And so first thing is just some random syntax notes. These things come up in our code all the time, so I thought it might be interesting to just show them. Var is like auto, in that you can throw anything in there, except that C# has no concept of a Voldemort type. So, you know, what are you going to do there? Then in .NET, all strings are UTF-16. So that's just a little note that W string there, which is a UTF-16 string in D, matters a lot. And my favorite is D's shorter syntax for variable arguments. The first thing we're going to get into, I'm going to poke some eyes here with properties. In C#, we have two different ways to declare a property. The first one says, I want to make a field with property syntax. And that's the top one there. And as you can see, you just say, I want to get, and then I want to getter, and then, oh, I don't want to be able to see this from the public world. I'll just make that protected. The bottom one here is a standard property. The upper syntax is newer and it was not in the initial release of C#. And of course, in D, we only have one way to do it, and it most clearly maps to this one, so when I do my properties, I will show them in the standard C# syntax. It's pretty easy, as you can see, because down here, you just kind of have to break out your gets and your sets, and then they match on a bracket level. But it can be a lot of just time-consuming, you know, just sitting there. And you can't really use find and replace. There's just that little bit of difference that says, if you're really good with regex, you might be able to, but if you're not, like me, sorry, I'm not a regex guy. I know, Andre. So, if there was a way to do this with an automated tool, this would be a fantastic thing to do with automated tools. C# uses properties everywhere. And if you're writing C# code, you've probably written a property, or, you know, a day. Some differences. The first one is that C# cannot take the address of a property. Now, this came up recently on the forums as an issue with properties. And here's what it gets you. In C#, we don't have this problem of if I have a delegate, I have to do a double parens to tell the compiler that I'm actually wanting to call the function, not get the address of the property. UFCS requires in D that we do that double parens thing. And that kind of looks silly, and for a beginner, not really something that they're going to know, so they're going to get the address of the property, the compiler's going to go burp and fail. Personally, I've been writing C# since it came out. The second beta came out in 2001. Since then, I have never taken the address of a property, ever. Now, I know there are people in this room who probably think that that's a useful thing, and if you have your use case, please come find me afterwards. Let me know what it is. I don't know. I have never done it. So I don't think it's something that is going to be common, even if it is something you do. So next up is namespaces. Now this one probably confused me the most when I was moving to, I actually have tried to port C# code. And this one really confused me the most because it took me a long time to figure out that I could not do system.text. And in C#, you can just sit there and say, okay, well, I want a new namespace. And you just add a dot and a new identifier, and you can just keep going on down the list. So you have to do something like that with the text in a different folder. And here's my experience with them. C# namespaces. C# and .NET in general are big on what they call composition, which means we can sit here and we can take little files and we can compose this namespace entity. We can also do that with classes and using something called a partial class, but that only works if we have a namespace, because a partial class in the same file, does anyone really write code like that? I mean, you know, why would you? The other interesting thing is that this has taught me to write code that structures itself logically as opposed to based on a file system or some other more arbitrary metric. I have code that is in a different folder completely that happens to be in a certain namespace that has nothing to do with the folder it's in. Now, Walter, in his talk, mentioned some reasons why you can't go beyond these modules. However, I don't think that anti-hijacking or any of those things have ever been a problem in in C#. Because you can add new methods via UFCS in C#, and if the class is partial, within the same, what they call an assembly, you can keep adding on little files as your class, but outside of an assembly, you can't. And so C# still enforces the idea of you can't get in there and overwrite somebody else's function call. You know, there is one way, but it's a class way, and you have to inherit the class, and it's actually basically a virtual function. So because of all of this, a lot of the code we wrote, we're actually trying to slide new types into existing .NET namespaces within their base class library. And this was done because we write code generation software. It's one of the tools we wrote for our main software that we write. And we needed a way to say this type is actually part of the base class library in terms of our code generation, because when you in C# when you use namespaces, you just, like in D, you say using instead of import, and you just keep going. And so we use this feature of C# a lot. In fact, I will show you a little later a link to a library that has exactly no unique namespaces to it. They're all .NET namespaces. So here was the process I used to convert our namespaces to D. You recreate the corresponding directory structure to a degree. See this leaf, what I call a leaf namespace here, this final namespace? That has to be a D file. So the regular expressions namespace in .NET's not very big, so your D file might only be 20 or 30,000 lines. Move all of the C# source from that leaf namespace into a single file, place the single file in the correct directory, set module name, and it will work, because you're now importing your package module name. Really, modules aren't namespaces. As near as I can tell, D doesn't have an analog to namespaces that really works well yet. We'll get into some stuff later with dips that people have talked about that would solve a lot of it. In C#, what we have is we can say, a lot like in D, class, nested class, nested class. It's probably best to think of of D's modules as like a superclass surrounding a whole bunch of types in C#. And this one got me hard. I did not know what to do with this until I came up with a method of handling it, because I wanted to do something like regular expressions and then have regular expressions D and then just import the package and hoped that it got the D file. It didn't. And this leaf namespace is a source file thing. It really does encourage source files of unusual size. And is Jonathan Davis here? Sorry, man. std.datetime. I had to bring it up. But if we had the ability to import std.datetime and it's broken out into 10 files, it wouldn't be as big of a problem. And that is one of the things that C#'s namespaces really do solve. They encourage small, readable source files. And combine that with the fact that we can't compose anything from small files into bigger namespaces, you can end up with some pretty monstrous source code files. And of course, I can't extend a module. Now that I'm fine with. It's that it's very hard to extend an existing namespace. Say I import somebody else's library. I have no access to the source code. They've just given me a bunch of DI files and a static library to integrate. I can, in theory, throw my source code in there, but as a library writer, if I need to extend, say, Phobos Phobos is open, but it's a good example because it's the standard library. If I need to extend the standard library with my own types that are imported with, how do I do that? Right now, I don't have a way to do that. So this is a GitHub link to the project we have. It's just some simple utilities we wrote for C#, and that's the one that there are absolutely 0 new namespaces in it. Now, we can help. We can use public imports. And we'll get in a little bit on the next slide as to how I propose to get around this for now. And here's a simple example of what the system directory, so in .NET, everything starts with system instead of std. So we would just have a module, and we'll call it imports. And then we will start publicly importing all the various packages, if you will, or they could be D files. I don't know how one would choose to do that. And then you end up with something that looks like this: system.imports, and that will import your package, your text package, your collections package .imports, and it will pull in all these files just kind of by the way it works. Now, this is how you would have to currently do it in D 2.062, which I believe is the current shipping version, until we get these 2 dips. And we might not, I don't know, there hasn't been any, this is approved and going in. It resolves almost all of the limitations, because what they do is they say, we are going to say if I import std, it would take all of them, smash them up, and import everything. Now, we probably don't want to actually do that for our code, but we could say importing std.datetime. We'll get all the datetime stuff. It could be split across 10 files, and D will silently port them all in because it knows that it's importing a whole package. I believe Andre was the one who wrote the dip 16 here, and that's pretty much exactly what he described. So I want to give credit to Andre and Martin Noack for writing these 2 dips that solve almost all the problems except composability. But if we can solve all these other problems, I can deal with the lack of composability. I might not like it, but it's not a big a deal as having to sit there and write, okay, I want to import these 10 different modules I have to make our stuff work. And next up, this is one of my favorite things about D. This is actually why I got involved in D. And so this is one of the ones where I have nothing bad to say about D. Yeah, I know the past 15 minutes I've been ragging pretty hard on D. But you see those constraints down there? I'm sure you guys are familiar with that term from D. That's it. That's all I've got. And I can't tell you how many times I've hit the need to say, well, my constructor really needs to have 3 arguments that have to be this. In D, I'm fairly certain, I haven't worked out how to do it yet because I haven't had a chance to get this far in my code conversion, but I'm pretty sure I can tell it how many arguments my constructor needs. And of course, there's all these other things that I don't even know what are in D's constraint system. So really, you can consider D's templating system a very large superset over C-sharp's generics. They work the same way. They even use the same angle bracket syntax. It's just that D can do so much more that when you start porting your code to D, you don't even realize that you're using the template system. It just slots in, starts working, and you kind of go, well, that's cool. I didn't have to do anything for that, which was another thing that I really liked about D's template system. And so here's a simple, I thought about trying to pick a more complicated example, but it just got too big for a slide, and I didn't want to have to pull up an IDE and show that around. So this is a simple C# generic class with a constraint. That's the where t semicolon. Now, see that list T down there? We'll get into that later. Because it turns into an array. Now, in D, we can concatenate arrays, but the list type in C# is significantly more expressive. So, D syntax says the same thing that C# does, with about 20% less characters. Go D. I like less typing. So, and it works the same as any other. So yeah, it just works. This is one of those ones where your C# code will just work. You port it in, you bring it in, and I've done this. I built a list type for D when I was porting code, and I brought in stuff that used it. Hit the compile button. Well, that was too easy. Now, the next few slides are just going to be some lists of mappings between D and C# LINQ and std.algorithm. And Walter's actually responsible for this based on a conversation we had a few months ago. I didn't even realize that these two mapped until we sat down and talked about it. But it turns out LINQ is the tool that makes, in my mind, C# usable. We write collections all over our C# code and our D code. And because we're dealing with things like, particularly in our code generation software, we're dealing with things like, well, I have 20 elements I need to store and generate. And we use LINQ almost to an excessive amount to pull out exactly what we need. So in this case, I'm looking at this and I go, okay, distinct. It took me about half an hour to figure out that UNIK, I think that's supposed to be unique, actually did the same thing. So the big takeaway from any of these lists is that sometimes the names don't match. And you need to sit down and read the documentation in std.algorithm to figure out how exactly the LINQ operations you're using match with what's available in D. And sometimes, as is the case here, I might be wrong on this. I just couldn't find in the documentation where there was an average thing. So I wasn't able to include it on my list here. Don't worry too much about long count in C#. That's just a way to return a count as a long. And I couldn't find a sum, although I'm pretty sure it exists. The documentation on it just wasn't clear as to what it does. Go for it.
We don't have average. Well, you can sum with a reduce.
Right.
But it's kind of tenuous. You got to accumulate two, so you got to do a reduce with two functors and then kind of do the division. Anyway, so Average, I think we should have. It's a very common sort of typical relational link SQL whatnot operation.
Yeah.
Some is in actually it's in there's a pull request I wrote for it.
Oh, okay. Well,
So definitely we should sit down and actually complete that list and make sure everything is covered.
okay. Well, that is good to hear, actually, because LINQ is, we actually use LINQ in C# for another thing that I haven't mentioned here, which is data access. You can use LINQ as a SQL query generator using LINQ to SQL or Entity Framework, and then you're just writing, your query in code, and it gets compiled down to SQL and sent off. You don't have to worry about it. So the more you can map your std.algorithm or your LINQ to SQL, the easier it actually can be to write an ORM. Now, this one I'm not sure on, because C# has then by, but when you read the documentation, it almost looks like it's just another name for order by. But it's not very clear. Typical Microsoft, they obfuscate. So I didn't include them, but I do believe that if you just use sort again, it would do the same thing. Don't quote me on that. I might be wrong. Then by could be like a second ordinal thing. Yes, Andre?
There's a multi-sort function I wrote relatively recently for std.algorithm, and it uses like a very big number of comparators, and essentially it sorts by the first key, and whatever is equal it sorts by the second key, and so on. So probably multi-sort would be fulfilling then by and then by descending.
Cool. Yeah. Now, these are just some other ones that I couldn't categorize. I was very happy to see that where has an analog. I use where in practically every LINQ query I write. And these others, group by, contains, repeat, these are all kind of general ones that I use quite a bit. So, as I said a couple times, this list may or may not be complete, and Andre's filled in a few of them for me. The one thing I can say for sure, there are some that are available in D that aren't available in C#, or that I couldn't understand the names of what the meant and couldn't map them. And here was an interesting one that kind of surprised me. D has a map function. C# doesn't. You have to, it's like Andre said, you have to sit there and piece together the actual functionality, and you do that by using select mini and group by. So if you see select mini and group by in your C# code, you can mentally say, that's a map. That's really what I'm doing there. So, fortunately, most common operations do exist, and it is relatively easy if you know the names, and I can make this list available online later of at least the mappings I've found, and if people want to add to them or come up to me later and say, you forgot my favorite one, that's fine. I don't know all of std.algorithm. It's another one of those huge D source files that just kind of runs on forever. This one, though, as I read, your internal semantics may differ. And because of that, you absolutely must check to make sure that your D algorithm that you wrote matches your LINQ algorithm in terms of what it gives you. Because we are dealing with different code. Andre's smart. He might have had a better idea than the Microsoft guys. So you have to, and I cannot stress this enough, actually test your ported LINQ code. Just based on what I read in the docs even, it sounded like some of them might be a little different. D containers for C# programmers. Now, notice the red one there? That is because C# does not have anything like a singly linked list. They don't do it. I don't know why. List of T over there is actually most analogous to an array of T. And that's an implementation detail in C#. I don't know why they chose to do it that way. This one is a little complicated. You have to go read the documentation pretty closely on sorted set and sorted dictionary, but they really are red-black trees underneath. And they say it in like the remarks section below all of their giant list of properties and functions and other stuff like that. So if you see sorted set in .NET 4 code, you can just replace it with, oh, that's my red-black tree, and I'll just do fine there. Unfortunately, containers is something that I'm going to have to rag on D for a little bit here, because we can do basics as long as I know what the various conversions are on this screen. I can do your basic add, insert, remove type operations, and I was incredibly pleased to find that std.algorithm would work on these things because they support range interfaces. Range interface is actually one of the things I love about D. Oh, here, we're just going to define a compiler spec that says you're automatically going to get this if you fill out these 3 functions, and it will work with all of this stuff. That was really useful. However, here's a partial list of containers available in C# that have no mapping that I can find in D whatsoever. Now, internally, we don't use any synchronized or read-only collections. However, you see these concurrent ones here? We use every one of them. We write C#5 async await code. We love it, but without something basic like a container that is thread safe, it really limits your ability to write code that is actually multi-thread safe without putting a lock in it. Now, in C#, concurrent dictionary has a very fine-grained locking mechanism based on, it's a hash table, so it's got individual sub-buckets, and it will lock one bucket but leave the rest open for reading. We use concurrent dictionary in every program we write. So without concurrent dictionary, we're stuck. We can't move forward. Now, the deprogramming language, this is a library problem. The deprogramming language probably has better tools than C# does to actually write these collections here. D has all this great support for message passing in multi-threaded environments, and it has std.parallelism and all of this great support, except that, Andre, poke, we need containers. Now, if we had even a basic container implementation that we could build off of and say, okay, well, this is kind of how containers are built in D, we could start. All of these are just variations on a theme. You know, I've got an observable collection, for example, is a list with exactly one new parameter. It's an event that you wire up and says, okay, every time you add, remove, delete, insert, whatever, an item into this thing, I'm going to fire this event. That's it. So you can actually just subclass list and create an observable collection. As far as I know, there are no queues and stacks in D. That could be wrong. That could be existing under another name. I don't know. So I'm going to show you something that's very close to what we do. This is another pattern that we use in all of our code. And this is my favorite thing I can't do in D, and I meant to change it to yet, because I'm pretty sure that Andre will eventually get our allocators figured out. So what we do is we have a simple property, and by the way, all this code is going to be in C# because I don't have a way to build it in D yet, and we'll get to the reason for that here in a second. All I do is I have a simple property, and all it has in it is 2 function calls, get value, set value. And in D's properties, this would be even easier. I would put the code for that directly within the property. So that's actually a plus for D's properties, except. And then we have another static property here, and we're going to register a whole bunch of information about what exactly we're working with. So we're going to register the actual name of the property, the type that we're going to return, or excuse me, that would be the type that owns the property. So we have to tell this system, okay, you exist within this type. And it has to be the concrete type that you're working with. So, and that's for actually inheritance reasons. It needs to know where in the inheritance chain it lives. We have to give it a default value. Now that default keyword is something that I could not find in D. Now, it might exist in the standard library. The standard library in D is actually quite large. And I discovered that as I was going through here, and that is a plus for D, is that it actually has a standard library that approaches the .NET BCL. So I could not find a default, and all that does is it says, whatever this type is, I'm going to give you the default value. If you're an object, I'll give you a null. If you're an integer, I'll give you a 0. Yes? Thank you. I will set that up. So anyway, you're going to see a slide where I mentioned that I didn't know what default, if there was a default, so you can ignore that. Thank you, Walter. And this is kind of the heart of the implementation of what we do. This is an abstract class, so we force you to inherit from it because by itself it really does nothing. All it has is a concurrent dictionary. Now that's very important because using these two functions, get value and set value, we're going to say, like for example, if I want to set that string, add or update the value in the concurrent dictionary. Now, a concurrent dictionary maps to a hash map if you're like from Java, and that's what you know. So all that's really going on here is instead of actually storing the information directly in like a backing field for a property or directly with the property, we're going to go up here and we're going to say, we're actually going to store that information in a concurrent dictionary. Now that gets us some very interesting capabilities. Because a concurrent dictionary is a non-blocking writer, a non-blocking reader and writer, I can now access that property from any thread, and thread safety is guaranteed. It will not corrupt. I was talking to some, I think it was Mr. Held last night. He called this a very small, very fast in-memory database. And that is kind of what it is. When we tried this code within our test environment, we were able to get 5 million asynchronous operations on 4 threads per second. Now, that was an artificial test. We don't recommend using this pattern if you're big into high-performance compute. You'll probably still need to do it the old-fashioned way because the data contention on concurrent dictionary, at least the way Microsoft's chosen to implement it, once you get over about 50% writes, performance tends to really fall off. I don't have any graphs to show you of what that looks like, unfortunately, but that's been our experience with it. So, as I said, this is a pattern for what we call concurrently mutable data. I can have 4 threads running, some reading, some writing, on the same piece of information. The only thing we can't guarantee is order. It will happen in whatever order the scheduler schedules the threads to run. That's somewhat out of our control, and we kind of had to say, well, it is what it is. It still works, and we write a lot of, I don't know if all of you are familiar with WCF, Windows Communication Foundation, or service-oriented architecture, but we write a lot of networking code, and we can have 10 incoming threads from the net coming in all at once. And 2 of them might need to modify the same piece of data, and there might be one over here, and there might be a different piece of data on the same object that needs to be modified. And all this is happening on different threads. And we had 2 options. Synchronize to the UI interface thread, scary, slow, or come up with a different pattern that allowed us to just, okay, come on. You all can come in as fast as you can, and we'll update the data and send it on. There's my use as default. We can fix that. Our current implementation, which is we have an open source toolkit that you can go look at. That's here. We also do a concurrent queue for managing what has changed recently. It's just a list of what changed and when. So you can actually go back and look at what the network has done to your data. And we also use SHA-2 hashing functions because the one thing we can't have is a collision in names within a type. And so that's where that name thing that you saw back here, that name right there is actually hashed out to verify that it is unique to this class. The implementation, as you saw, it's about 15 lines of code, including braces. There's not that much to it. We're just missing a few things. The language support is mostly there. The library support has a little bit to go. If we got SHA-2, or probably even SHA-1 we could pull this off with, and proper, I call them collections still because I've been doing C# for 12 years now, but if we got real containers and lots of them and concurrent containers, because I know that there's support for concurrency in the language right there. This should be easy to do, but we haven't done it yet. The last thing I want to talk about before I get onto my summary slide here is if you use any of these namespaces in your code, in your C# code, any at all, can't port. Except with the two exceptions that are posted here, because all of these containers are generic, you can port them. But in .NET, they have the concept of a non-generic container. And in that case, you would probably just want to move it to a generic container and move on with life. This one pained me. I didn't want to put this one in here. And the reason for that is because D actually does file I/O. But in .NET, the only kind of file I/O we have is stream-based. And so because D doesn't have streams yet, I had to throw it in there because if you're using system.io, you're using streams. And there's no way around that. The system.data is .NET's database access base classes. A lot of like entity framework comes out of system.data. And this one surprised me, and I don't know if it's just hidden somewhere and not well named, but I couldn't find anything on timers in D. So, yes, Andre, they're there.
Well, it's got to be somewhere in date time.
Oh! So there's nothing in date time about timers, huh? No. Okay, well, I guess we have some more code for you to add to std.datetime.
There's a stopwatch by Shu, I think, right? Yes. So there's at least embryonic support, and
okay.
There's discussion about kind of migrating that into the up-and-coming std benchmark. So, there's work on that, but I'm a bit more worried about the others.
Yeah.
Well, about the
this one right here. Oh, yes, sorry.
About the I/O thing, it's kind of my fault that there aren't streams, is because I've been against streams, and I think we ought to be using ranges instead of streams.
I'm not actually going to argue that with you. The reason I'm including it on here is because all .NET I/O is stream-based. You're going to have to rewrite your I/O for D completely. So what I found is helpful is comment out the using, find out where your code breaks, and then start rewriting it in D-style code as you move it across. I don't see any other way to get around that problem because in .NET it is all stream-based.
Okay, I just feel that ranges are a much superior solution than streaming.
I'm actually with you on that because we can compose std.algorithm into the range.
Yes, exactly.
That makes perfect sense to me. I'm noting this here so that people who do work with C# can go, well, I'm going to have to start over, and that's fine. It's just I'm trying to explain,
All right.
Yeah, what I had to do, and this one I don't know how much it matters anymore in this day and age, but when they mean printing, they mean literally physical output to like a dot matrix or a laser jet, and I am not sure how much that matters anymore. We still use it, but in our industry, we're still kind of 10 years ago, and we're trying to change that. But so this is my last slide here, and I kind of want to issue a call to arms on a couple of things, particularly containers. The D language, you can find almost everything you need in terms of C# at the language level. But these 6 namespaces here, that is a significant portion of the .NET base class library. And you cannot write a non-trivial program in C# without using the .NET BCL. You would probably, if you're working at all with strings, you'll probably import system.txt, for example. Now, on system.txt, I want to make a note. std.uni is currently in review. std.uni has a lot of what system.txt does. So when it passes, that namespace, I will take that off my list of things that I can't use. So D is getting there. We're really getting there in terms of being able to just say, my C# code, I can write it there and I can move it to D. Yeah, it'll be a little bit of work, but with some find and replace or regex magic, we can just do this really quick. And because containers are one of the major weaknesses compared to C#, .NET's, sorry, Andre, I keep picking on you and your containers. I kind of want to end with a question of how can we today move forward with containers? And an answer I'd like to throw out there is I've done a lot of research on containers because I've had to write a lot when I'm porting D code. Interfaces seem to be a big deal when you're writing containers. And one of the big things that the community seems to have is we want to know what our interface to something looks like. We're constantly fighting over the name of this or the name of that. And if we could create an interface that defines the containers we want, so say we want a stack. Well, let's create a stack interface and hash out now what we want it to look like. I can come in, I can write, and then tomorrow I can come in, I can write my own stack implementation, and when Phobos gets one, as long as they both match the interface, I can swap them out silently and I'll never have to know that I used my custom one or the Phobos one. And I see this interface point come up all the time in discussions on how to write container libraries. And I think it's something the community could do without having to bother Andre over his allocators. We can get off his back for a little bit. We could come up with our own implementations. Say I wanted to write an observable collection. Well, I fill out the interface, add my one little thing I need to make that work, and I can go on my way and I can start porting D code. But without that level of at least saying, well, we're going to make sure that we at least have some way to swap these things out underneath when it does become time to fill up the standard library with containers. I don't see any way to really get started on that.
I guess I'm a little puzzled because containers support the range interface.
Right.
Now, a particular container flavor may support some additional methods in there, but at a fundamental level, a container needs to support input ranges and output ranges.
Correct. So when I talk about interface, I am talking about, so a range has its 3 basic functions, and then there are some ranges that have their extra functions, but they're very simple, the interface, right? I'm talking about getting more specific. Add, insert, remove, clear, empty. We have length, and we don't need capacity. But I'm talking about, let's get specific, because the difference between a red-black tree and an array, in terms of what they can actually do, is very different. And by specifying a deeper interface, I can then go back and say, well, I've got a dictionary and I need to convert that to a D dictionary. Okay, well, okay, I've got a range interface. That gives me some basics. But for example, in a concurrent dictionary, we have a function called add or update, right? Well, that function applies to all concurrent dictionaries. You're always going to have an add or update in a concurrent dictionary. It's actually part of the pattern that you use to build it. We don't have anything like that in D yet.
Well, so this is a longer discussion. Maybe it's a good topic for the informal meeting tonight at Hotel Aloft.
I will be happy to have that conversation. I will be there tonight.
Right. As well as, ranges or streams or both. Here's what I think the dynamics is right now. Most people who need containers complete a complete array of containers. So, okay, a complete collection of containers. Oh my God. Okay, a complete suite. Thank you.
There
of
we go.
containers are going to essentially they're very interested in efficiency, and that means anything we lose compared to C++'s style of containers with embedded allocator, everything statically bound, everything like goes straight to the silicon, burns into it if possible, etches the silicon. I think anything that loses over that is going to have this drawback on its back. So in that regard, the design, which is also very valid of interface-based and hierarchy-based containers, which is common to C#, Java, and a few other languages, I think it's going to be tenuous to integrate with that requirement. Also, the whole notion that we want the allocators to be statically bound and integrated with containers is just simply put a complicating factor, which kind of we need to think about. I'll talk more about that tomorrow, by the way.
Oh, cool. Well,
so it's a long discussion. It's not a simple thing like let's just do that and we'll be great. Happy.
That's why I think the idea of interfaces is important, because it gets us away from this idea of we have to have a standard library implementation. Because somebody can come up and say, well, I've got this really high speed that does exactly what I need. And we can say, okay, we'll match it to the interface, and you can say, and then we can say, oh, well, and if you need to, for testing purposes or whatever, just try out the standard implementation. I think that would be useful. You can also say a lot of people don't want to write their own containers. For example, I use concurrent dictionary. That's straight out of the .NET BCL for that piece of code we wrote there. There was no custom code there, although there's certainly a case where I would. Yes?
For starters, when you're saying interface, hello? When you say...
Doesn't like you.
Can't hold this right, apparently. When you say interface, do you mean interface like the keyword interface, or do you mean the API?
Right now, I'm talking about like the keyword interface, like an IList for example, in C# is the list interface, and it doesn't describe everything that's available in the actual list type, but it describes the basics.
Okay, well, I'm sure that's long discussion in terms of how we want to cover that, since for the most part we're going for templated, not interface in that sense. But if the concern is API, well, it does need a little bit of work, I think. Andre did do a fair bit of work in terms of laying out what the API is supposed to be for anything in standard.container in terms of the main API. So if someone is looking to implement a container and get it into standard.container, they
Right.
know roughly what the API is that they need to implement it. So our main holding factor there is just the fact that people aren't spending the time writing the containers and contributing them.
Well, I might even have to sit down and do some of that myself. Yes?
Seems to me that if you're porting C# code over anyway, why don't you start with the C# interfaces? Offer that as a suggestion.
And in fact, I was going to do that. Say, well, the C# interfaces, they are very complete, and they cover 90% of the use cases that your average user is going to hit. That's actually where that operation list came from. That is an iCollection interface right there, which is the kind of the base interface for generic containers in C#. So, iList actually just inherits from iCollection and says, well, now I'm going to make myself a generic interface. And that's as far as it goes. It adds a couple other convenience functions, but that is kind of what I'm talking about, because the better specified the interface can be, the less interest there needs to be on exactly when a certain implementation becomes available. I can sit down and say, okay, well, I need to write a list type today or an array type today. But I have this interface I can code against so that if somebody comes along with a standard library and says, oh, well, I've got a better implementation than yours, or they change it underneath, my interface still works. I've got everything I need. I don't have to change anything. So if that's everything, we can talk later tonight about interfaces.
Give them a hand. Thank you.